Hello everyone, Swagatam and very warm welcome to this amazing platform of PW Gulf. My name is Aman, your favorite maths buddy, and today we continue our series of revision with the chapter which is one of the most awaited one, the chapter of trigonometry. So the first question one should ask is why trigonometry and what exactly is trigonometry? Now this is a new branch of mathematics. Till now we have learned about geometry, we have learned about mensuration, we have learned about number system, we have learned about stats. Till now we haven't been introduced to trigonometry. We are being introduced to trigonometry at this moment, and what exactly are we going to deal with? So these are the two very basic questions which I am going to address in the upcoming time. Now first let's see what are we going to learn in this session. So the table of content is such that I'll be introducing you to, and when I say introduce, I'll be talking about the questions of why and what exactly is trigonometry. Once we are clear on that concept, then we can learn the chapter of trigonometry. In trigonometry, we are going to talk about trigonometric ratios, one of the most important topic of this chapter, or I would say the foundation bed of this entire trigonometry thing. Right now we are learning in grade 10, even though if you go in grade 11th or 12th or you go on to do the research in mathematics, then also the same concept will be helping you out. And finally, we'll talk about trigonometric identities, where most of the question comes from. So there will be many questions will be coming from trigonometric identities asking you to prove two different things. So that also we'll be talking about. So first thing first, why are we learning trigonometry? So for this part, I had a very simple answer. Now this day, let's say you are roaming around somewhere and you reach to one of the tallest building. I hope you can understand what building is this. So if some friend of you asks like, okay, what is the height of this building? Now, other than searching on Google, I don't think you have multiple options. Earlier, that was not the case. These days, we are having technology at our fingertip. So easily we can answer everything. How far is sun from us? How far is any particular star from us? These questions these days can be easily answered. But in ancient time also, people had answered these questions. How? Basically, they use some kind of a mathematics. They use the mathematics of trigonometry. Trigonometry help us to calculate the distance. Trigonometry help us to calculate the height of any particular building. And also it is used in navigation, it is used in astronomy, it is used in designing and the structural part as well. So it has a huge application. For example, a very basic thing. Some summer day, you were just sitting on the rooftop and were enjoying the sun over there, sun bathing basically. So not exactly in summer, I want to apologize for that part, but aeroplane goes by. In my childhood, I was very interested when an aeroplane goes by. So I called one of my friends, okay, come see, aeroplane is going by. Now, by the time I called other person, the aeroplane would have covered some distance. This much distance was covered. Now, someone can ask me in the meantime, let's say I took 30 seconds or let's say I called immediately, I took 10 seconds only. How much distance was covered by that aeroplane? This is a very important question. How much distance was covered in a particular time? So this question can also be answered using trigonometry. So I hope you are realizing the part what exactly trigonometry does. So trigonometry helps us to calculate the distance, it helps us to calculate the heights and all. And that is the reason when you look up to your textbook, I hope everyone does that. When you look up to your textbook in the content part, when you are introduced to the chapter of trigonometry, the next chapter following it is the application of trigonometry. And most of the questions over there deal with the height and distance over here. So how does trigonometry work? That's also an important question. So let's see how does trigonometry work. Here we have a tall building. A person is standing and looking at the tip of the building, particular building. Now, we can connect the dot from the eyesight to the particular top of the building. Fine. We can join a line, make up a line from the base as well. And now we are having a particular figure. If you observe, what kind of figure is it? It's a right angle triangle. Easy to understand. What kind of a triangle? A triangle having a 90-degree angle. It's very important that the basics are covered, otherwise it's of no use. So we are having a triangle with one angle as 90 degree. Now in this triangle we know few of the sides. For example, we know the distance. At least we can calculate this much amount, that how much distance we are standing at from the particular base of a building. We can have some other things as well. We can know any particular angle like this. What is this angle exactly? So right now, let's say if I'm viewing at a person who is having a same height, I'll be viewing horizontally. But let's say some big person, I don't know who might be this big person, a humongous person come in front of me. So I would have to look like this. So basically what changes over here? The elevation changes, the elevation changes. So this angle over here is the angle of elevation. It tells us at how much degree we have to do the movement. Fine. So we are having that angle, we are having the base distance, this distance, we are having this angle, we are having. So basically from this, I can calculate this distance. Alright. So what happened over here? We use right angle triangle property and calculated the distance, or I would say the side length of a triangle. In the similar manner, when I was talking about aeroplane, in the case of aeroplane also, this time we were having two different triangles, both being the right angle triangle. And we use the same thing. We use that viewing angle, we use that horizontal distance and same things. Basically, I'll be talking about how are we going to use. But at the moment, I'm trying to just tell you basically what are we going to do in the entire session over here. Alright, I hope you are getting a clarity. So, by now, I have at least answered two parts. Why are we learning it? What is the application of trigonometry? And how does trigonometry work? So if someone asks you at the end of the session, what exactly is trigonometry? You should have something in front of you. So at least for that, I have a definition for you. Trigonometry can be easily described using a triangle. Basically, you are using a right angle triangle. In a triangle, if I ask you, what are the dimensions which defines a triangle? So there are two things which defines a triangle. One thing is angle. There are three angles involved. So angle, and another thing is side. So the relation between the angle and the side, is the study which is called as trigonometry, as simple as that. Any other way we can define it? You can break down the term trigonometry. Trigonometry comes from the word tri, gon, metron. Tri means three, gon means sides, and metron means measurement. Trigon. Basically, we are talking about triangle and we are talking about the measurement of triangle. So basically, we are dealing with a triangle, and in specifically at the moment, I will be interested in right angle triangle. So this exactly is what trigonometry is all about. I have told you about the application, so you should not take this chapter lightly. In this chapter, we are going to deal with some new terms. So you should be excited about that part, and the application of this chapter are huge. Alright, so on that note, we move forward. Before I talk about the foundation part of this chapter, I want you to introduce the very basic concept which you have already known, but it's important that you are being introduced once again so that you don't leave any sort of confusion at all. So when I was talking about a right angle triangle, here we have a right angle triangle. In right angle triangle, we are having three sides, which is common in every triangle, right? But in this particular, we have given a nomenclature. What kind of a nomenclature? There was a mathematician, Pythagoras, a Greek mathematician. He had studied a right angle triangle very well. He gave a theorem by his own name, which is known as Pythagoras theorem, which will be used here as well. One of the most widely used theorem in mathematics. Over here, first thing is that the longest side in a right angle triangle is called as the hypotenuse. The longest side in a right angle triangle is called as the hypotenuse. Wherever be the triangle, the longest side will always be hypotenuse. Now we are left with two sides. Now the name of these sides have been given as perpendicular and base. But the perpendicular and base might change accordingly from where you are viewing these sides. What does that mean? If I am viewing from this particular point C, this vertex C, here we have angle theta. This theta basically means I am standing at point C at the moment and looking towards A. So basically this exactly is a perpendicular AB. This AB side is a perpendicular. Today this is also known as opposite side. A common name to it is opposite side. And for the base we call it as adjacent side. So opposite side and adjacent side. Now this perpendicular and adjacent side might change. How? Look over here. Now I am standing at point A over here. Look at the perpendicular. The perpendicular earlier was AB, now it is BC. So what changed? The viewing point has changed. According to the viewing point, the perpendicular and base will be named. But the hypotenuse is remaining constant, which is AC. So one should be very thorough and clear from where we are viewing the angle. So if someone asks what is the opposite side over here, opposite side in this case is BC. What is the adjacent side? Adjacent side in this case is AB. In the previous case, it was a different case. So this was the clarity about perpendicular, base and hypotenuse. Now the important thing, Pythagoras theorem, as I mentioned. What exactly is Pythagoras theorem? For Pythagoras theorem, if you are clear and sorted about the hypotenuse, perpendicular and base, the Pythagoras theorem gives you the relation among the three. How? It's very simple to understand. Over here if we know that this is the hypotenuse. So the hypotenuse side length square would be equal to hypotenuse side length square would be equal to the square of perpendicular when added with the base square. So it will be written like this: perpendicular square plus base square. I hope you have learned about the concept of Pythagorean triplet. So if I quote a number like 3, 4 and 5, this is called as Pythagorean triplet. How does it work? The square of 5 is equal to the square of 3 plus square of 4. This simply means that the hypotenuse length, if it is 5, so in that case the base length is 4 and the perpendicular length is 3. 3 and 4 can be easily exchanged. It's not for sure that okay, this is 3 or this is 4. It can be any one of those. But hypotenuse is the longest one, so we are sure that that will be 5. This was the very basic of a right angle triangle. This is nothing new. You have already learned. You have learned about right angle triangle. I hope you know the other classification of triangle as well. Do you know about the obtuse angle triangle, acute angle triangle, right? And other than that, also we have a classification based on the side: equilateral triangle or scalene triangle. So these are also a classification of triangle. If the basic of a triangle is known, now we move on to understand the part of ratio. Before I talk about trigonometric ratio, you should at least know the concept of ratio, right? I am pretty sure that most of you will not be very clear about the concept of ratio. If I ask you what exactly is ratio, you would say, sir, ratio is 5:7, A:B. But that's not the clarity about the ratio. What exactly ratio mean? Why do we use them? As I put forward, why we are learning trigonometry? Because it has a humongous application. In the similar manner, ratio is nothing but a method to do the comparison. So let's say if I am going on a bicycle at a speed of 20 km/h. On the other hand, my friend is going on a bike. Any bike it can be. There is a huge difference over here. So he is going at a speed of 200 km/h. Let's say hypothetical. Don't take it literally. Now, if I want to do the comparison, one way of doing the comparison is by doing the subtraction. 200 minus 20. He is going at a speed of 198 km faster from me. 198 km/h faster from me. But that's not the true method. The best way is to do the division. Division is also a method of doing comparison. When you do the division, in that case what happens? You will get what? You will simply come up with 200 divided by 20. Now what does this give us? So you do the cancellation over here. You are left with 10. How will you code this relation? You will simply say that the friend is going 10 times faster than me. If now I am going at speed of 10, my friend will be going at a speed of 100. If I am going at a speed of 40 or let's say 30, my friend will be going at a speed of 300. That's what this relation does. So division over here is a better method of doing the comparison, and this method is called as ratio. So whenever we want to find the comparison of two quantities, we'll simply divide. So let's say if I want to find the comparison between the perpendicular and base, I'll do the division simply. How? AB divided by BC. And in this case of trigonometric ratios, since it is trigonometric, I hope you are clear. Trigonometric simply means relating to triangle. So we are going to do the comparison of the three sides of the triangle. So let's talk about that and start on that. I hope the concept of ratio is very, very clear, because without that you cannot proceed any further. In trigonometry, when we are talking about a triangle, the triangle is in front of you. I told you we have to take the ratio of two particular sides. So let me start from the perpendicular with the hypotenuse. I hope you are clear over here that this is AB and this is AC. So if I say AB by AC, this is the ratio of what? This is the ratio of perpendicular. With the hypotenuse. Now perpendicular can also be called as the opposite side. It's up to you. Don't get confused that okay sir, in our textbook it is written as opposite side. It's the nomenclature. Some person can be called as Ram at his school and Chiddu at his home. So that name difference can always be there, but they both are the same person. perpendicular by hypotenuse. This ratio we have given a specific name, and which is one of the most widely used name across trigonometry. The name to this ratio is called as sine theta. It is called as sine theta. Now, what is sine theta? If someone asks what exactly is sine theta, sine theta is the name given to the ratio of the two sides. Which two sides? The two sides involving the perpendicular and the hypotenuse. So in a triangle, don't look forward to this particular triangle, because like this triangle, the name can change. AB can change into AC or BC or whatever be the thing. But you should always be clear. What is the viewing angle? Theta over here. What does theta work? Theta over here is telling you about the angle. So which angle? The angle from which you are viewing. The angle from which you are viewing. So over here, when I'm talking about angle, we are standing at point C. We are standing at point C. So that is the reason point C is having angle theta. Point C is having angle theta. So I have written sine theta. Sine theta will be having perpendicular by hypotenuse, where perpendicular would be decided according to the theta. According to the theta. And sine theta should be remembered like this only. Sine theta is important trigonometric ratios which will be always used, because only two trigonometric ratios are the one which derive rest of the four ratios. How does it work? Now let's me talk about the second important one. I hope you are clear about sine theta. Sine theta should be just remember in the manner perpendicular by hypotenuse, or you can say the opposite side by hypotenuse. This should be written down in your notebook. You should not be waiting any further. The next ratio which comes in this league is known as cos theta. The next ratio is called as cos theta. What happens in cos theta? Nothing can happen. Basically, we are talking about ratios, so definitely we'll be doing the comparison. So which two side would we choosing this time? This time we will be taking up a base along with the hypotenuse. Hypotenuse is remaining constant both in sine theta and cos theta. So base divided by hypotenuse is called as cos theta. So over here I am writing base divided by hypotenuse. You can also write this as the adjacent side divided by the hypotenuse. Over here for this particular triangle, the name would be BC divided by AC. BC divided by AC. Alright, so this is cos theta. Cos theta relates with the base to the hypotenuse, and sine theta relates the perpendicular to the hypotenuse. And again mentioning this part that this base and perpendicular will be depending upon from where you are standing, from where you are viewing, or what is theta over here. These are the two ratios which can derive the rest of the ratios. In total, how many ratios do we have? I hope you should be clear. It's not something that you would have already known. Over here, when you see a triangle, you are getting to know that okay, three sides are there, which you already know anyhow. If there are three sides, if I want to take the ratio of all three among one another, so how many total ratio would we come up? So this is a question of logic, right? So I hope being a math student, you can think about it. In total, we'll come across 6 ratios. In total, we'll come across 6 ratios. We have already talked about 2 ratios, sine theta and cos theta. I'm telling, if you are thorough with the concept of sine theta and cos theta, rest of the 4 ratio will always be easily known to you. So I hope we are taking the note of sine theta and cos theta. Moving on to the next 4. So first of all, let me talk related to sine theta and cos theta. If you know something that is sine theta, then you can already know the other ratio which is directly related to sine theta, which is known as by the name of cosec theta. Cosec theta. So what is the relation between sine theta and cosec theta? Sine theta and cosec theta are reciprocal of each other. If I say sine theta value is A, so cosec theta value will be 1 by A. If I say sine theta is 1 by 7, so in that case cosec theta will be simply 7. They will be reciprocal of each other. So you can automatically tell me now which two sides ratio will be a thing of cosec theta. For this you need to remember sine theta. Sine theta is perpendicular by hypotenuse. So in this case of cosec theta, we will be having hypotenuse divided by the perpendicular. Hypotenuse divided by the perpendicular. I am not writing AC divided by AB because that is very obvious now. Alright, so cosec theta, how do you need to remember cosec theta? It is a reciprocal of sine theta. So don't need to learn cosec theta, that cosec theta is hypotenuse divided by perpendicular. That's not the way forward. That's not the way forward. The only way forward is to remember this relation sine theta is equals to 1 upon cos theta. Very important relation over here. Alright, next. Since I have told you a reciprocal of sine theta, so definitely one thing is for sure that accordingly, like sine theta, cos theta will also be having a reciprocal. So what is the reciprocal of cos theta? The name of the reciprocal of cos theta is called as sec theta, 1 upon sec theta. And now it's very obvious, if I know cos theta is base upon hypotenuse. In the case of sec theta, it will be hypotenuse by base. So this is the next relation which should be remembered. This is the next relation which should be remembered. How many ratios have we talked about till now? We have talked about in total 4 ratios. We have talked about total 4 ratios, but still 2 are left. Again, the next of the 2 will be derived from the same sine theta and cos theta. But till now, I expect that these 3 or 4 are very, very clear. First, these 2, sine theta being perpendicular upon hypotenuse, and cos theta being base upon hypotenuse. Fair enough. Next thing, what are the 2 ratios left, sir? Now in this also there is a name nomenclature. Someone might ask us, sir, why sine theta, why cos theta? Sine theta is basically a sine. Basically sine comes from a Greek word sinus, and it has its root also in Indian trigonometry. But when I say Indian trigonometry, the mathematicians who have started working on trigonometry in India. So it comes from circle, jiva, ardha jiva, half chord. That translated into trigonometry, translated into Greek, was converted into sinus, which was reduced into sine theta. And cos theta is nothing but complementary of sine theta. So in reduced form, it is written as cos theta. Alright, very simple nomenclature, but that part is not as much important for you, so I'm not going into that much of history. If you are interested in history, so there is one homework for you. You can on your own search about who is the father of trigonometry, and then if you are interested, definitely you can go on and read about what his contribution to the trigonometry part. Alright, coming to the next ratio. Now, if I say I am going to take a ratio of sine theta by cos theta, now you might say, sir, we were dealing with the sides, why are we dealing with the ratios itself? By dealing with the ratio, I want to infer you some other thing. Let's see how does it work. Sine theta is basically perpendicular by hypotenuse. What is cos theta? Cos theta is base by hypotenuse. Now first thing is everyone comfortable doing this division? Perpendicular by hypotenuse divided by base by hypotenuse. An important part. Many people struggle in doing the division of fractions. So for that, there is a very, very basic trick. What trick is there, sir? If I say there is 1 upon a, or rather let me write it in different manner. If we are having a ratio, or I would say a fraction a by b divided by c by d, what we need to do? Always convert the division in the form of multiplication. How can we do that? So over here, what is division, what is multiplication basically? Multiplication and division can be similarly working as a by b is same as a multiplied by 1 by b. So when I am dividing a by b, so I can convert division in the form of multiplication when I convert b in the form of reciprocal. So I am doing the reciprocal of it. So it will be a by b multiplied by d by c. If this is getting complicated for you, however, it should not be, because it's a very basic thing. But in case you are feeling that this is getting complicated, so what do you need to focus upon? You need to focus upon a very simple thing. When they are giving you a division, you have been given a division, what do you need to do? You need to do a simple multiplication. This multiplication should go like this, and this multiplication should go like this. So here we'll be getting a numerator, here we'll be getting a denominator, and you'll get the answer. 2 basic sine waves. Sine waves? Why do we call them sine waves? You will realize this when you go on studying the sine theta function in grade 11th. So for each and every function we have a graph, and sine theta graph looks like something this. Alright, so don't indulge any further. Let's talk about the division over here. When you do the division over here, you'll come up with a calculation with a final answer as perpendicular by base. Now this is the ratio of the sides, and we have directly reached to this through this formula of sine theta by cos theta. This ratio is called as tan theta. tan theta. The name has been derived from tangent. I hope you know what tangent is. Something related to circle. So trigonometry is not isolated to triangle. When I say trigonometry is related to triangle, it doesn't mean it is limited to triangle. It has an important role in triangle, but in other subjects, not other subjects, basically other chapters as well, it has a huge important undertaking. Alright, tan theta over here is perpendicular by base. Perpendicular by base in terms of the side ratio. But over here we have derived one formula for tan theta directly. In case we don't know the sides, but directly sin theta and cos theta have been given to us, we can always calculate tan theta. I can write over here tan theta is sin theta divided by cos theta. So basically I am deriving a ratio from other two ratios. Sin theta divided by cos theta. An important formula. Clear? This was our fifth ratio. One ratio is still left. So I hope you should realize how the sixth ratio can work out. So over here tan theta was there, so there would be a reciprocal of tan theta. The reciprocal of tan theta is called as 1 upon cot theta. This is the last ratio which was left. And for cot theta, very simply we can write up the ratio of the two sides. So ratio of the two sides would be base by perpendicular. So for the last 15 minutes I have been talking about the ratios and have finished all the 6 ratios. There is nothing complicated over here. The names might be a new one. So it's like you have gone to a foreign country and the names have converted into William, Mark and Smith and all these things, but still they are the same human beings, nothing different over there. And the name have been given to the ratio of the sides, and the sides are very common thing which you have been learning for very long for the case of triangle. So over here we have the summary of entire thing which I have been iterating for the past 15 minutes. The 6th ratio have been given over here. Sin theta is the ratio of perpendicular by hypotenuse. Cosec theta is nothing but the reciprocal of sin theta, so hypotenuse divided by perpendicular. Cos theta is a new ratio which is base by hypotenuse. These two sides are related. And sec theta is nothing but the reciprocal of cos theta. Finally tan theta can be derived from sin theta as well as cos theta. These two will help us to reach to tan theta. So tan theta is sin theta by cos theta, and when you do the division you will come to realization that it is perpendicular by base, the ratio of the two sides which is perpendicular by base. And finally from tan theta the reciprocal of it is called as cot theta, which is base by perpendicular. That's how this triangle works. And in this entire summary, one thing is very important which I have been iterating again and again. It totally depends which is the perpendicular, which is the base. If you have taken a wrong perpendicular, wrong base, entire thing will be a house of cards, will go away, right? So I hope you have taken a note of it. If not, if you are too lazy to take a note of it, you would have taken a screenshot for this part. Moving on, any concept cannot be completed if we do not solve any problem on that, because from the solving of the problem we can consolidate the concept. So here we have a very simple problem, one of the most simplest problem in trigonometry. This is the question which we will see for the first time and from my end for the last time as well. It says that tan A over here, rather than theta, they have given the name to that angle, tan of A as 4/3. Find the other trigonometric ratios for angle A. You have been given 1 trigonometric ratios, and for the rest of 5, they have given you to solve them and give us the final answer. First thing in such kind of a problem which we need to do is to always do the construction of a right angle triangle. This is our right angle triangle. Okay, now give it a name. We have been given A over here, B and C, A, B, C. In this triangle, they say this is a right angle. Over here, we have been given tan A. So this angle A is our viewing point. If tan A is given to me as 4/3, let me write it over here. Tan of A is given to me as 4/3. It's important that by now you should realize in your head, tan theta is a ratio of which two sides? Tan theta is a ratio of which two sides? Tan theta is a ratio of perpendicular by base. So when I take the ratio of perpendicular in this particular triangle over here, it's important to realize what is a perpendicular. Perpendicular for angle A is the exact opposite side. This is exact opposite side. So BC is the perpendicular and AB is the base because it is adjacent. It is adjacent over here. So for this the ratio have been given. If the ratio is 4/3, so it can be 4/3. It can be what? 16 by, understand in this manner. 4 by 3, or if I multiply by 2 over here, 2 over here, it will be 4 into 2, 8 by 6. It can further be multiplied with 3 or whatever number you want. You can go on. So ratio basically is indicating the numbers, but the numbers can be different because it totally depends whether you have reduced them or not. So that is the reason we can take them in the form of 4k. I can write perpendicular being 4k and the base being 3k. This is a better method to go forward with. But what we do in general we say that we know that okay, this k would be there and it will be removed over a period of time. Let's take the value of k as 1. If I take the value of k as 1, I am taking directly the perpendicular and the base value as 4 and 3. Here I will not indulge in any more calculation. I'll leave up to you to find out the hypotenuse. I hope that you'll pause the video and quickly give me the hypotenuse value, which should be coming out to be 5. There should be no waste of time for this because Pythagorean triplet I have introduced to you already, 3, 4 and 5. So 4, 5 and 3 over here. If I know the hypotenuse value in terms of the ratio itself, now from here I can derive all the ratio, because what we need for the ratio, we need the side length. If we have the side length, I can write all the ratios. But for one ratio, there was no requirement to do all this. If 10 of A is given to me, at least one of the ratio I can directly write, which is cot of A. What is cot of A? Cot of A is nothing but the reciprocal of tan of A. So I'll write it as 1 upon tan of A. So from here, 1 upon tan of A, it is 4 by 3. So 1 upon 4 by 3. Here we get what? 3 by 4. One ratio we have found out without using any of that figure, without using any of that calculation. But that is not all, because anyhow we need to find the rest of the ratio. So let's go forward and find rest of the ratio. Sine of A. Sine of A is perpendicular by hypotenuse. We have calculated the hypotenuse value. We have known the perpendicular side. So this comes out to be what? 4 by 5. See, why I was telling that k I have taken the value of 1. Because when I take the ratio 4k divided by 3k, k cancel out, 4 by 3. Similarly over here, 4k by 5k, k cancel out, we are left with 4 by 5. So if I am having sine of A, I can get from here cosec of A. Cosec of A will be the reciprocal of sine theta, 1 upon sine of A. So the value will be reciprocal of 4 by 5. It will come out to be 5 by 4. Very simple task, easily done. Next ratio, 1, 2, 3, 4. 4 ratio done, 2 ratios left. So we are having next ratio as cos of A. Cos is base upon hypotenuse. The base value we have taken as 3. So 3 by 5. No complication at all. Simply you have to do one thing. So calculate the third side and take the ratio. That's it. If this is known to you, then sec of A will also be known to you, because that will be the reciprocal of cos of A. So the value comes out to be 5 by 3. This is one of the most simplest question that can come related to trigonometric ratios. The point for this particular question was to make you understand that from one ratio, if any one of the ratios is known to you, you can calculate the rest of all the ratios. As simple as that. Now, let's see the different variety of question in this particular problem. Here we have a problem which says in triangle ABC, right angle at B. So I have already told, so one thing is for sure, we have to do some construction over here. So let me draw the triangle first. This is the triangle for me. It says in triangle ABC, right angle at B. If they have clearly mentioned right angle at B, so I have to make this 90-degree angle and name it as B. Now I can say this is A, this is B, and this is C. Sine of A is 7 by 25. Sine of A is 7 by 25. Alright. Then the value of cos of C. Be very thorough when you are reading the question. Most of the students, they make a mistake. They say, so sine of A, they are asking the value of cos of A. I can find out. I know that the ratio is given 7 by 25. I'll find the third side. As we have done the previous question, I'll give the value of cos A. But you have done everything correct, that's fine. But one of the very basic mistake over here is you haven't read the question carefully and you have done a long effort that was not required at all. Understand why I'm saying so. If they have given sine A ratio as 7 by 25, so I know this is the ratio of perpendicular by hypotenuse. Alright, so again in the same way I can go for 7k by 25k. So I am taking the value of k is 1 over here. So 7 is a perpendicular. For A, this is the angle. This is the angle A. For this, the perpendicular is this one. So 7 is this side. H is the hypotenuse. It will not depend on the angle. Hypotenuse is the longest side AC. So it will come out to be 25 simply. 7 by 25. Fair enough. What has been asked? They are asking you the value of cos of C. They are asking you the value of cos of C, not cos of A. There is a difference between cos of C and cos of A. Where I was giving you the basic of triangle, I was not wasting some time. I was making some clarity to you that if the angle name changes, everything changes. Now you are not going to view from this angle. You are going to view from this particular angle. This is the angle where we are interested in. When I am looking from this particular angle, everything changes. What everything? The perpendicular and base changes. For this particular angle, if this is theta, for this perpendicular angle, this is the opposite side. So in that case, this will be the perpendicular. If this is the perpendicular, this will be our base. This length will be our base. Let me name this as base. Hypotenuse will remain as it is. So I hope the green color is making you distinguish between angle A and angle C. So now if angle C is having a perpendicular as this one and base is this one, so writing cos of C will not be that difficult task, because cos is the ratio of base by hypotenuse. Base by hypotenuse. Base over here is not this one. Base over here is not this one. This would have been for angle A. For this one, we have this as base. For this, we have this as base. And base value we have already known because we have been given the ratio. So base is 7 over here. Hypotenuse is 25 over here. 7 by 25 is our answer. What if the ratio was given? Same is the answer. Answer over here is option number A, 7 by 25. I hope you are getting the realization. It's important to read the question carefully. It's important in trigonometry that you always recognize which angle they are talking about. By changing the angle, everything changes. Fair enough? A very important question. Moving on to the next one then. This time they have given you the value of tan of A, they have given you the value of cos of A, and they are asking the value of sine of A. I don't think I need some kind of a help over here so that you can solve this one. It's very simple. If you use the relation of tan theta being the ratio of what? Tan theta is nothing but sine theta by cos theta. I can understand for many students, the things might be very quick. They seem very fast. That okay sir, just now we have learned the formula and using the formula so quickly I am not able to remember it. You will be remembering if you are using it frequently. So make sure that after the session you practice more and more trigonometry, and you will be also thorough and will be saying that it's very, very simple. Tan theta is given to me, not given to me, we know that tan theta is sine theta by cos theta. In this we have been given the value of tan of A, we have been given the value of cos of A. From here we can calculate the value of sine of A. So let me put the value. I am assuming theta as A. So this is 78 by 15 is equals to sine of A is what I want to calculate upon cos of A value is given to me as 15 by 17. So when I go on to do the calculation, now from here the calculation would be very simple. Sine of A would be what? This goes over here in terms of multiplication. So this is 78 by 15. 78 by 15. This over here was in division. So when it goes on the other side, it goes in multiplication. So multiplied by 15 by 17. So over here 15 cancel out 15. We are left with 78 by 17. One mistake is there. You might be wondering, sir, option is not having this thing. The basic mistake over here is this 7 written. This should not be here. This should not be here. The correct ratio would have been 8 by 15. The correct ratio would have been 8 by 15 rather than 7 by 15. So that is the reason in the option you can see 8 by 17 rather than 78 by 17. The correct answer would be 8 by 17. This 7 has to be omitted from everywhere. The 7 has to be omitted from everywhere. It's basic typing error, nothing more than that. So final answer 8 by 17. Very simple question. The concept was to make you sure that there is a relation between the three ratios, tan theta, sine theta and cos theta. If any two are given, you can always calculate the third side. Just like if any one side is missing for you, using the two sides, you can calculate the distance for that. Next final problem on the ratio part, which is very simple and highly conceptual. If you are not realizing this part, you haven't understood ratio very well. They're asking you the multiplication of sine theta with cosec theta. Sir, how would we do that? I told you while explaining the ratio, there is a relation of sine theta with cos theta. What is the relation? Sine theta is nothing but reciprocal of cosec theta, or you can say vice versa. Or you can say vice versa. If I transfer this cosec theta on the other side, what would happen? Nothing would happen. Only one will be left. Only one would be left. I will be writing this as sine theta multiplied with cosec theta, and on the right hand side we are left with only 1, which is our answer. Anyhow, you don't need to think in this manner that I will be transferring on the other side. You need to think in this manner also, that okay, sine theta into cosec theta. I can write sine theta as 1 upon cosec theta, which is being multiplied again by cosec theta. So cosec theta will be cancelled out, we will be getting 1. Anyhow, 1 should be the answer from wherever you reach to the final answer. That's important. So that was about trigonometric ratios. I took a lot of time to explain what trigonometric ratios are because it is an important thing. As I mentioned, it is a foundation bit. Once trigonometric ratios are clear, then you might ask, so why these fancy names and why theta is involved over there? Does it has a role to play? Yes, it has a role to play. If you remember when I told you about the definition of trigonometry, I told you that trigonometry is a relation between the sides and the angles. So how are sides and angles related? Now, if triangle is given to me, and in a triangle this theta is given to me. In a triangle, theta is given to me as 30 degree. Alright. Along with theta, this side length is given to me as 5. This hypotenuse is not given, this base is not given. Can I calculate the hypotenuse or the base? Since using Pythagoras theorem, 2 sides were involved, 2 sides were needed basically. You can calculate the third side. But in this case, only 1 side is given and 2 sides have to be calculated. But the additional thing is coming up. That additional thing is angle over here. So ultimately, if 2 things are there, 1 angle and 1 side, you can always calculate the rest of the 2 sides. It's very simple. And how would that work? If you remember, you have learned about the ratio of sine theta. Sine theta is nothing but perpendicular by base. Hypotenuse. In this case, I know the value of theta. But how does this help me? I'll tell you how will this help. Sine of, what is the angle? Angle is 30 degrees. Sine of 30 degree equals to the perpendicular, which is 5. So 5 by hypotenuse. Now, for trigonometric values, for trigonometric functions, at specific angles, they have certain value. For specific angle, they have certain value. What does it mean? It simply means that sine of 0 would be having some value. Sine of 30 degree would be having some value. Sine of 45 degree would be having some value. Sine of 60 degree would be having some value. Sir, what value would be there? Let me show you what value would be there. Here we have the complete chart of different angles. For different angles, very specific angles we are talking about. We are having a lot many values for different angles which are in between, like between 0 and 30. We'll be having a value for 10, 20, 1.4, 1.5, 2.5, everything. But right now at this grade, we are limiting ourselves to specific angles. Which specific angles? We are limiting ourselves to 0, 30 degree, 45 degree, 60 degree and 90 degree. But sir, how are we going to read this table? That we have to understand with a basic understanding that over here we are having a list of trigonometric ratios in column. In the rows we are having the different angle. So for example, if I want to read the value of sine of 60 degree, so sine 60 degree will move into that particular row over here. So sine of 60 degree. Here we come to 60 degree. The sine value 60 degree will be root 3 by 2. If I say 10 30 degree, so here we have 10, move up till the column of 30 degree. So 10 30 degrees 1 by root 3. Sine of 45 degree, sine of 45 will be 1 by root 2. This is how you need to read the values. Other than that, you need to make some observation. Observe the value of sine theta and cos theta starting from 0 to 90 degree. Now you will find that the values are interrelated something. Somehow they are interrelated. Here we have 0, here we have 0, here we have 1, here we have 1, 1 by 2, 1 by 2, root 3 by 2, root 3 by 2. Now, basically they are inverted image of each other. Sine at 0 is giving you 0, cos at 90 is giving you 0. Sine at 30 degrees 1 by 2, cos at 60 degrees 1 by 2. So if you can remember this correlation, you can always go forward very easily in the calculation part. Since someone mentioned you the value of sine of 30 degree, you can easily say that sine of 30 degree will be equal to cos of 60 degree, and opposite will be also true. That means cos of 30 degree will be equal to sine of 60 degree. This will help a lot in the calculation part. At the moment, this is just an observation for you. View it in the form of observation. You will learn the concept behind it also later. It's not that complicated. Sometimes just sit in your leisure time, draw a triangle and see. I had made you solve one question. Sine of A was given, cos of C was asked. Something like that you will make the realization how sine 30 degree equal to cos of 60 degree. Another observation which you need to make over here. The values are ranging from 0 up till 1. 1, 0. So they are lying between 0 and 1. They are lying between 0 and 1. But for the value of tan theta, you can see here we have a value root 3. I hope you know the value of root 3. Root 3 is basically greater than 1. Root 3 is greater than 1. And that is the case for all tan theta, cosec theta, sec theta and cot theta. So only for sin theta and cos theta, the value remains between 0 and 1. For all the 4 ratio, it is greater than 1. Another important observation, you'll observe that there are multiple places written as not defined, not defined, not defined, not defined. It is again not that complicated. If you apply your brain, you'll realize this part. How? I told you that sin theta by cos theta is equal to tan theta. That means if I say what is tan of 0, tan of 0 will be sin 0 upon cos of 0. But if I say tan 90 degree, what is tan 90 degree? Tan 90 degree will be equal to the sin 90 degree divided by cos 90 degree. Observe the value in the table. Sir, please give the side so that we can see. Now see, 1 by 0, 1 by 0. If you remember the rational number, you will remember for rational number, in the denominator we can never have 0. We can never have 0. So this is not defined. And that is the reason everywhere where the 0 is in the denominator, everywhere they have mentioned not defined, not defined, not defined. And in all the 4 ratio, this will be the case. In all the 4 ratio, this will be the case. Now I expect without me telling, you would have always taken a note of this table and you would have taken a screenshot. And you have this in front of you somewhere on the sidelines, because based on this, we are going to solve few questions which are very, very important. What questions, sir? First of all, let me tell you why I am learning this one. Or you are learning. I had already learned. This is now your time to learn. Over here, this figure is to indicate you that how do we get these values? How do we get these values? That how do we know that sin 0 is 0? How do we know that cos 90 is 0? How do we know that cos 0 is 1? Basically, this is a triangle. This is a triangle ABC. So over here, this is our perpendicular. This is our perpendicular. Over here, we are having a perpendicular. Fine. So what we did, we started reducing this angle A. This angle is being reduced. Understand in this manner. This is a scissor or this is a stapler. This is a scissor or a stapler. Right now it is having a huge angle. Over a period of time I am reducing the angle between both the sides. Both the arms basically. So what will happen? The angle will be reducing. Angle will be reducing and the line joining these two tips will also be reduced. So the perpendicular side length would start decreasing when I decrease the angle. See in this figure. The side length is reduced to this much. The angle is also reduced. Up till this step, this is also reduced. Come to the final point. They will be reaching a point when the scissor, two arms will be joining one another. They will be joining one another. Now, what was perpendicular? Perpendicular was joining the two tips. If there is two tips are interconnected now, what is the length of perpendicular? The perpendicular length in that case becomes 0. And along with that, perpendicular length becomes 0. What is the angle now? Since they are coinciding each other, both the arms are coinciding each other, the angle also becomes 0. Theta also becomes 0. Observe, what is sin theta? Sin theta is perpendicular by hypotenuse. So sin of 0 will be what? Perpendicular. That value has been reduced to 0 in this case. Sin 0, the perpendicular value has been reduced to 0. So irrespective of whatever be the hypotenuse, sin 0 will always give us the answer 0. Sin 0 will always give us the answer 0. Or you can understand for cos theta as well. What is cos theta? Cos theta is base by hypotenuse. So when I am saying the two arms coinciding each other, the two arms are coinciding each other, that means that the length for both base and the hypotenuse have become equal. In that scenario, cos theta, which is base by hypotenuse, If both become equal, the value becomes 1. And for that, you can now understand why cos 0 is 1. In the similar manner, for all the other particular angle, we have the values. It's not a hypothetical thing. Some mathematician has already done the hard work for you. You have to just consume. You have to consume, and if you can reproduce it in a better work, that will be your achievement. So trigonometric ratios for a specific angle have a specific value, and you need to remember this particular table over here. Alright, so now in this note, I'll first of all talk about a very simple thing which I was trying to mention in the very starting about specific angle. Here we are having a triangle, one side length is given, one angle is given. Now we can find out multiple things. Over here, they're asking you to find the length of BC and AC. This length over here and this length over here. First of all, if I talk about sine of 30 degree, sine 30 is what? Perpendicular by hypotenuse. Perpendicular value is given to you for theta, that is 5. Hypotenuse value you can always find sine 30 degree. Right now, you don't remember. That is the reason I told you to put it on the sidelines. The table should always be in your sidelines so that whenever asked for, you can look into it and you can point out that, okay, this is the one. Over a period of time, when you repeat this activity for very long, you will become comfortable with it. So sine theta, sine 30 degrees, since you don't know, let me show you it over here. Sine of 30 degree is 1 by 2. Sine of 30 degrees 1 by 2. I'll use it in over here, this question. 1 by 2 equals to 5 by h. I hope this is not that difficult, just like the division of the two fraction. Very simple thing, you can do the cross multiplication, and from here you can find out the value of h as 10. I have find out the one side for you, which is side length AC. Now the next homework for you is to find the other length, which is BC. I hope you know which ratio do be used and what value would be used for that particular case. Very simple task. This was just to show you why the specific angle, their values are important to us, and why at the first place trigonometric ratios are very new thing and an important thing to learn in trigonometry. Alright, because sine theta, sine A, cos A, people think, why are we using in this term? Do they have any practical application? These are the practical application for each and everything. Next question, just to make you understand how does this work. They're asking the value of 2 10 30 degree upon 1 plus 10 square 30 degree. Now 10 square 30 degree, I want to elaborate on this part. If it is written in this manner, 10 square 30 degree, this is same as 10 of 30 degree whole square. So don't get confused upon this part. These both are the same thing. 10 30 degree value, you should be knowing that 10 30 degree is 1 by root 3. From here, you can put up the value in the given equation and you can find out the value of the given expression. Not the equation at the moment, the given expression. And you will come to the correct answer if you put this value over here. Another thing which you can do on your own. Finally, one final question on this part, then we move on to the final topic. I know you are getting impatient now. So, this final question on this topic, then the final topic we have. We are given sec theta into sine of A. Wherever it is written in this manner, directly sec of A, sine of A. This basically means there is a multiplication in between. There is a dot in between, and which shows that there is a multiplication. There is a multiplication over here. This is given to you as 0. Now, trigonometry is all about interchanging these ratios. After this, you are going to learn about trigonometric identities. Over there, you will learn that they are all about interchanging one trigonometric ratio into other. Sec of A can be written in the form of cos theta or cos of A, because sec A is nothing but it is a reciprocal of cos of A. So, sec of A can be written as 1 upon cos of A multiplied with sine of A equals to 0. Now look at this ratio. Basically sine of A is in numerator, cos of A is in denominator. So sine of A upon cos of A, which is nothing new, we already know that this is tan of A. Tan of A is equal to 0. You should remember from the given table that the value of 10 becomes 0 at 0 degree. From here, we had find out that A would come out to be 0 degree. That has been asked to you. The correct answer is option number A. Very simple task. I hope easily done. So this was all about trigonometric ratios. For entire 1 hour we talked about trigonometric ratios. Now we move on to the application or the use of trigonometric ratios further, which is related to trigonometric identities. One final question I will be talking about, this one. I didn't know that I brought up such interesting questions for you. So over here we have sine of a minus b which is given to you as 1 by 2. And another ratio given to you is cos of a plus b is equals to 1 by 2. I will be leaving this question for you because just before this summary, I had given you the summary of another chapter which is known as by the name of pair of linear equation in two variables. This question over here is an amalgamation of trigonometry and pair of linear equation in two variables. You will realize how. Sine of any particular angle is 1 by 2. So basically I should be thinking about for which specific angle sine value will be 1 by 2. I should easily come to the point that sine of 30 degree is 1 by 2. See these two things, this 1 and 2. Do the comparison of 1 and 2. You will realize that sine of 30 degrees is 1 by 2 and sine of a minus b is 1 by 2. So this basically indicates a minus b is equal to 1 by 2. As simple as that. And similarly, for this relation, cos of a plus b is 1 by 2. We will think about cos for which value? Cos 60 degrees is 1 by 2. So a plus b is equals to 60 degree. Not 1 by 2. It should be 30 degrees. Sorry. It should be 30 degree. Now you have two variables a and b and you have two equations. I hope you can apply some linear equation to variable and find the value of a and b. A something and b something. So this was just to show you why in mathematics nothing can be learned in isolation. Everything is interrelated and you have to understand in that manner. Coming to the part of trigonometric identities, the final thing which you have been waiting for quite long. For trigonometric identities, one thing need to be understand. In trigonometric identities, we are not going to do something new. We have to first of all understand where does trigonometric identities come from. I am not going to do the derivation of entire trigonometric identities. I am going to just talk about, give you a hint from where does it come from. So see, this is a right angle triangle. For a right angle triangle, there is one property which I have quoted which is always used. What is that property? The property of Pythagoras, theorem of Pythagoras. If I write the Pythagoras theorem for this, that is hypotenuse square will be equal to the perpendicular square plus base square, right? So let me write in the form of the nomenclature given to us over here. This is hypotenuse is AC square equals to AB square plus BC square. AB square plus BC square, correct? Now, this identity over here, this is not identity. What is identity? Identity is something for which every value works. This is not the identity at the moment. So over here, if AC square is equal to AB square plus BC square, if I put up the value, over here, what I'll do first of all, I'll divide the entire given equation by one side. Let me divide by AC. Divide AC square on both sides. If I do the division of AC square on both sides, what will happen? AC square divided by AC square. Let me write if you have any confusion. AC square divided by AC square. Over here, AB square by AC square. AB square by AC square. Plus BC square by AC square. BC square by AC square. Now, just observe. AC by AC, both being square, the division will be 1. But AB square by AC square, observe over here, AB by AC, that means perpendicular square by hypotenuse square. That can be written as perpendicular by hypotenuse whole square. And this is some nothing but sine of theta. So sine theta whole square, which can be written over here as sine square theta. Now it's your job to look forward for the second ratio and you'll come with the answer of cos square theta. This is how you reach to the first identity of sine and cos theta. Sine square theta plus cos square theta will always give you the answer 1. Whatever be the value of theta, it will always give you the answer 1, and that is why it's an identity. And that is how it is being derived. How we have derived it? Use the Pythagoras theorem, divide by any one of the sides square. Now, if I divide by hypotenuse square, I come to this identity. If I divide by perpendicular square, I'll come to the second identity. If I divide by base square, I'll come to the third identity. And what are these three identities? To sum it up, we have these three identities in all. Sine square theta plus cos square theta equals to 1. Cosec square theta is equals to 1 plus cot square theta. Sec square theta is 1 plus tan square theta. Now, you are big enough now to understand that these identity can be transformed. What do you mean by transformed? Cosec square theta minus cot square theta equals to 1. If the identity is written in this form, don't get confused, sir, what it is written. It is same as this. You have just transferred cot square theta on the other side. Same you can do for sec square theta. So identity remains the same. They are not anything new. And don't try to mug up these kind of a thing. You need to just remember these three, and using these three you can do the interchanging part. If you are doing the interchanging part well, then that's fine. But these are the basics which you need to remember, and I hope you have taken the note of it or the screenshot of it, because these are very, very important things. I hope you are clear on the part of identity. Now we move forward to solve few of the questions related to identity. A very important thing. See the question over here. The question on its own will be seeming a humongous task. So this big equation cos square theta multiplied with 1 plus cos theta multiplied with 1 minus cos theta equals to lambda. Half of the student will leave it over here itself. They'll say, sir, this is very complicated. I'll not be able to do it. I'm not good at trigonometry. You are good at trigonometry. The only obstruction at the moment are you, because you're not trying to solve it. If you start solving, if you start practicing, if you pick up the pen and take the first step, everything will be logical after that. Observe in this given question over here. 1 plus cos theta into 1 minus cos theta. This is something like A plus B into A minus B. I hope you know this identity, A plus B into A minus B. Right now we are dealing with trigonometric identities. This is algebraic identity. So this is nothing but A square minus B square. So from here, I know that 1 plus cos theta into 1 minus cos theta can be written as nothing but 1 minus cos square theta. Observe 1 minus cos square theta. 1 minus cos square theta is again nothing but, if you observe, sin square theta plus cos square theta equals to 1. So if I transfer this cos square theta on the other side, it will be reduced to sin square theta equals to 1 minus cos square theta. It's not a new identity again. Many students will be wondering, sir, this was not taught. This was taught. I told you, you can frame the equation in whatever manner you want. You can transfer one to the other side. So now 1 minus cos square theta can be written as sin square theta. So over here I am replacing the two terms with single term. So I am writing this as cosec square theta into sin square theta. Now if you remember, I gave you one question where I told you cosec theta into sin theta, what is the value? Over there the value was 1, because both are reciprocal of each other. I can write cosec square theta as 1 upon sin square theta into sin square theta. These two will be multiplied and the final answer will be 1. Observe how simple the question was, even though the identity looked very big. So finally the value of lambda comes out to be 1. This is the problem, and nothing have been used, only two things. One algebraic identity, one trigonometric identities, because maths is not learned in isolation. Every chapters would be involved. Observe the question once again. We move on to the next one then. Here we have the next question, which says sin theta plus sin square theta is given to you as 1. This is given to you as 1. And now they are asking cos square theta plus cos raised to the power 4 theta. Sir, we have only dealt with square terms. They are asking for to the power 4. How will we be able to do it? See, that's what you have to be more courageous while seeing the problem, while reading the problem. Because if you are getting scared just by reading the problem, one thing is for sure, now you are on the back foot to play the ball. If you are on the back foot to play the ball, you are gonna duck, or I would say whatever. If you know cricket, you understand most of the players like to play on front foot, because playing on the front foot give you an attacking mode. So over here you are not in the attacking mode. Why you would be in the attacking mode? If you would be very simple, that you have to take some logical steps. What logical step? Let me write it once again. Sin theta plus sin square theta is given to me as 1. Fair enough. Let me do some transformation of the given thing. Let me transfer the sin square theta on the other side. This is sine theta equals to 1 minus sine square theta. If you remember, I just now told you the simple thing. You can transfer any of the thing from any other side. Sine square theta plus cos square theta equals to 1. So I can transfer the sine square on the other side. So it will come as cos square theta equals to 1 minus sine square theta. Right? If I replace this 1 upon 1 minus sine square theta with cos square theta, things becomes very simple immediately. Sine theta is written as equal to cos square theta. So basically cos square theta value is sine theta. If cos square theta is sine theta, what will be cos square theta whole square? Again, the term I have squared it. So it will be squaring on the other side as well. This will be sine square theta. So ultimately when they are asking me this, they are asking me sine theta plus sine square theta. They are asking me this value. When they are asking cos square theta plus cos raised to the power 4 theta, they are asking me sine theta plus sine square theta. What have been given to me? They have given the same thing, equals to 1. Final answer over here is 1. See, we have used simple identity. We have used a simple identity, and using that we have answered. The problem on its own might seem difficult. Let's move on to one final problem. Then you are free to go. Yeah, this is the one. Here we have the next problem where you have been asked to do the proving part. Now most of the, or I would say the majority of the question in trigonometry related to identities come in this form, where you have to prove the LHS equal to RHS. In such problem, what you have to do? Your approach should be clear. What approach? What would be your first step? Your first step should always be to do the transformation. Either you start solving LHS, reach to some point, and then start solving RHS, reach to some point, and then equate it. As simple as that. Do the transformation like this. Cot theta is written, so cot can be written in the form of sine theta or cos theta. And while you are solving this, use the logical thing. What logical thing? The trigonometric identities. Let's take one example, you'll get better understanding. So over here, let us take from the left hand side. Cot theta minus cos A, cot A minus cos of A, cot A plus cos of A. I'll write cot theta, I'll use cot of A equal to cos of A upon sine of A. Alright. I am replacing this cot value. So this comes out to be cos of A upon sine of A minus cos of A. Over here, definitely the denominator would be 1. Same thing is being repeated in the denominator with a positive sign. So cos of A upon sine of A plus cos of A. What I can do over here? What I can do over here? See, over here I can see the similar expression. I just take the common denominator and start solving. I'll take a common denominator of sine theta over here, or sine A. Sine A. When I take sine A, so cos A remain as it is. This is cos of A. In the other term, sine A has to be multiplied because 1 was there. So to make the denominator common, we have to multiply. So minus sine of A into cos of A. Fair enough? Divided by the same expression would be there, just the positive sign would be there. So I am not going in the elaborate form. So this will be written as cos of A plus sine of A into cos of A upon sine of A. If you remember when I told you the division of fractions, then I told you that how would you proceed? A upon B divided by C upon D. So D will be going on the multiplication with A. So ultimately sine of A will be in denominator, this sine of A will be in the numerator, and both will be cancelled out. You are left with a simple identity now. You are left with cos of A, which I will be taking common because this is cos of A. I am taking cos of A common. I am left with 1 minus sine of A. In the denominator again, cos A, I'll take cos A common, and I am left with 1 plus sine of A. Again, two things are common. So one thing is for sure, that I can cancel out one term. Both cos of A cancel. 1 minus sine of A, 1 plus sine of A. We are having cosec of A minus 1, cosec of A plus 1. Now, one way can be, you leave it like this and start solving the right hand side. You will reach to this point. Or you can go on further for this step itself. What I can do? I'll divide both the numerator and denominator by sine of A. When I do the division, what will happen? Since I am dividing a by b by the same term, so nothing changes. Don't think that okay, we are making any change over here. Few students are very smart. They on their own change the equation. That cannot be done. You can multiply by the same number in the numerator and denominator. You can divide by the same number in the numerator and denominator. But you cannot simply put up one term anywhere you want. That's not how things work. So dividing by sine theta, this will become 1 upon sine of a. When sine of a being divided by sine of a, so let me write it simply, sine of a divided by sine of a whole upon the same thing but with a positive sign, sine of a upon sine of a. In this case, you can easily observe some things can be very easily cancelled. Sine of a, sine of a, sine of a, sine of a. What are we left with? 1 upon sine of a, 1 upon sine a. 1 upon sine a is what? 1 upon sine a is cosec of a. So in the numerator, cosec of a minus 1 upon cosec of a plus 1. This is what have been asked over here. And we have done the proof. We have done the proof over here. Nothing. We have used a simple thing of transforming one ratio in the other form and some additional operation which you can think on your own, where to divide, where to multiply, so that I can form the desired result. One good thing about these proving question is you'll never get a negative mark, so you'll never lose a marks over here if your steps are right. Ultimately, you will be finally happy about that. Okay, I have done correctly, so I'll be definitely getting 5 out of 5 or 3 out of 3 or 7 out of 7, because there is no chance of losing the marks. Ultimately, if you have proved it, everything is right, because there is no calculation involved that okay, I might have done some calculation error. So that's the advantage of it. As much you practice, you get better in the form of these questions. So from my end, I do understand that this chapter is an elaborate one, and it totally depends how much practice you have done related to the proving questions, because proving questions can be of different category. It totally depends. If you have solved the different category question, then you will becoming comfortable with that. Immediately after seeing the question, you'll realize that okay, this is the first step of this question, because first step is the crucial step. If you haven't taken the first step, you'll never reach to this step where you're standing at the moment. So don't hesitate to take the first step. As much practice and as much experience you'll gain, you'll get better at the job whatever you are doing. So till then, have a great time. I'll meet you in the next session with a new chapter. Most probably it will be the application of trigonometry. Have a great time. Enjoy yourself. Meet you then. Bye bye.